Hi friends, Naji here. Welcome to my YouTube channel. We are continuing a discussion with LangGraph, and in this video we will be discussing on MapReduce, and we'll see how can we do a parallel execution using MapReduce. So this will be our agenda. We will be discussing on MapReduce design pattern, we will be discussing on Send API, and we will be doing the code example. So MapReduce, this is a high level discussion on the MapReduce. So in a MapReduce, what is actually happening is if we have a big problem is there, we will divide that into small chunks, and we will process each chunk separately. Okay, then we will combine them together and we will get the final output. Okay, so that is a high level design pattern that is followed in the MapReduce. And consider this particular scenario. We will have an array of numbers, and we need to find out which one is the biggest number. Okay, and what usually we do, we will split them into small chunks. So here we will have a chunk 1, and we will have a chunk 2, and we will have a chunk 3. So in chunk 1 we will have 4 records, chunk 2 we will have 4 records, and chunk 3 we will have 4 records. Then the next step is, in the map phase we can see, we will figure out which one is the biggest in this each chunk. So here we can see 98 is the biggest, here we can see 89, and 92 is the biggest chunk in chunk 3. So once that is done, we will combine them together and we will sort it, and we will try to figure out the biggest number from this small chunks, I mean this final chunk. Okay, so the one advantage is that we will able to process this in parallel. So this is only like 10-15 numbers, right? But in real scenario, consider we have millions of numbers are there. So if I try to do a sorting and trying to find out the biggest number, we may not have everything to be in memory, right? If we have a RAM size is there, right, it is very difficult to load all the numbers together, and sorting them is a very costly, right? So what we will do, we will split them into small chunks, and this will be processed in parallel. Then finally we will have the final result. So this will be fast, memory efficient, right? So that is how the MapReduce work, and we'll see how can we implement similar problem statement in LangGraph plus MapReduce. So this is what we are going to achieve. So we will have a topic. So what we are trying to do is, we will give the customer or the user will give a topic. Based on the topic we will create some subject, and based on the subject we will create some jobs, and we will try to find out which one is the best job. Okay, so that is what we are going to do. So see here, we can see we will have a topic, and the topic, and we will be giving a node. This node is the generate topic. Then once the generate topic is done, we will pass this generate topic to a send function, which is a special function in the LangGraph, which will dynamically create each node, and this each node has its own state. Okay, so this entire process has a common state that is shared among the nodes, but whenever we pass something to the send, we will able to keep a state with each this node. So this node has its own state, this node has its own state, and this node has its own state. So we will have a subject, and based on the subject we will create the jogs. Then all the jogs will be combined, and we will find out the best jog. Okay, so that is what we are going to implement. So all this generate process, we will be using the LLM to generate the so once we got that once we get the topic from the customer, then we will create the subject using LLM, we will create jobs using LLM, and finally we will figure out the best jobs using the LLM. So we'll see how can we implement this. So for that, I have my Visual Studio Code is open, and I have selected my kernel. Then first what we can do, we can import few imports. Okay, so here I can use LangGraph graph, I can import graph state, we can have a start, and we can have end. Okay, now from LangGraph we can import the send, and from typing we can import annotated, and we can import typedict. can import operator, and I can import OpenAI also. Here we are using the OpenAI, so you guys can use anything. You can use Anthropic can be used very easily. Also you can use Olam also. Okay. So from LangChain Open we need to use the chat OpenAI. Okay. So I believe we have everything except we need to have Pydantic also. I can import base model, and we can import the base model, and we can import the field. Okay. Then what we can do, now we can start creating the classes for this. Okay, so before class we can create some prompt. So first we will create the prompt that to create the subject. Okay, so here I can say that generate a comma separated list of between 2 and 5 examples related to the topic that we have given. So based on this topic we will create the some subject, comma separated subject. Now we can create some prompt to generate the joke. For that I can say that generate the joke about subject. So based on the subject that is given, I want to generate a joke based on the subject. Now I can have a prompt to best joke. So this is the best joke prompt. Here I can say that I will say below is the bunch of jokes about the topic. Okay, now select the best, correct the spell on this, select the best on it, on this, and we can say that return ID of the best one. Okay, here I can pass the jobs here. So these are my prompts. Okay, now we can create some classes to extract, to convert the NLP to the object. Okay, for that we will be using the base model, Pydantic base model, and here I can say that this is the subject and this is the list of string. So what this will do, this is the convert the NLP to a class structure, so will be easy for us to access that. Okay, so we will have a joke, so we will have jokes, we have a base model. Here I can have a the string is the base type. Now best joke, here we can have the base model. So in the base model that will return the ID of type integer. Now I can say that the description, Scalable description, index of the best joke starting with 0 index and should be greater than or equal to 0. So these are the 3 prompts, and these are the class models that will support this prompt. Okay, now we can create the model. So we'll be using the OpenAI model. Can use in the chat OpenAI. Here I can have the model GPT. I will be using the GPT-4o mini. So I have saved my OpenAI key inside my .env file. Okay, so you guys can go and create a env file, and you can also add the API key there. Otherwise you can give the API key directly itself. API key equal to, you can copy and paste your API key here. Okay, so both are fine for the POC type of project. Okay, now as I said, we have two state. One is the overall state. Okay, so for that I can create a overall state which will be the type dict, and here we will have a topic in the form of string. Then we have a subject. The subject is a list of subjects are there. I can say subjects. Now we have the jogs. Jogs are annotated because it is a list of one, and this will be operation dot add. So we will be using the reducer operator here, operator dot add. Now we need the best selected jog, which is in the form of string. So we have the overall state is there. Now we need to keep another state which is specifically for each node. Okay, each jog node. For that I can create a jog state. This will be of type date. Here we will be keeping only the subject. So this is the subject. Okay, now we have our prompt, our supporting class models and states are ready. Now we can start writing the functions or the nodes. The first node is generate topic. Generate topic. So here we will be accepting a state. The state is the overall state. Okay, so here we have the prompt, right? So what we will do, we will have a subject prompt is there. So we will be doing the formatting there, and we will be passing topic equal to state dot topic. So we'll see our subject prompt is something like this: generate a comma separated list between the 2 and 5 example, and we need to pass the topic. Topic spelling is wrong here, so let me correct. This is the topic. Okay. So here I am passing that particular topic here. Okay. So this topic will be sent by the or set by the user. Okay. So we have our topic is ready. Our prompt is ready. Now I can pass this into the LLM. So I have the response. Response is a type of subject, and we'll be using the model dot with structured LLM with structured output. So this will give what this will do. This will take the response from the LLM, and that will be converted to the subject class subject. Okay. So we'll be invoking the prompt. So we will have the response type, and we will return the subject. Subjects. So spellings, please take care of spellings, otherwise like you have to spend lot of time with respect to debugging. So I will be returning the subject. Okay. So the subject part is done. Now we can write the generate jog. Generate jog. So here in the generate jog we will have a state, and this state is the jog state. Okay. So this state will return the overall state. Okay. Here also we will have a prompt. So this will have the jog prompt dot format. Okay, what are all the parameters that we need to pass? Just go and check. We need to pass the subject. Okay, so here we will have the, you can say subject is state of subject. Subject. Now we will have the response. The response is of type job. Okay. Here I can say model dot with LLM structured output. With structured output, I can pass the job class, and we can invoke the prompt, right? We can invoke the model using the prompt. Now we will have the jogs, right? So this jogs will be, this is the jogs, and we will get it from the response dot jog, and this will be passed to the LLM model. Okay, so we'll see, we'll review this one more time, what is actually happening. So we will have a generate topic. So we will generate the topic, and we will get the subject. The subject will be assigned to the overall state. Okay, then we are going to call a generate jog. This is another function. So here we will have the jog state. So this is the individual jog state, and we'll take care of all those individual jogs, and we will create a jog with respect to this prompt. Then we will create the jog. These jogs will be updated back to here, the overall state. Okay, so this is must be a list. Okay, now we need to create that, we need to implement the send method. Okay, for that I can use a continue to job. Okay, here we will have a state, that is the overall state. If you are a little bit of confused, don't need to worry. So when we execute this, you will get a more clarity on that. Here what we will do, okay, so here we have we need to split our subject. Okay, we need to split as we discussed in the in this diagram. We need to split the subject, okay, and we need to create the topic in a multiple nodes. Okay, that is what we are going to do. For that uh, we will be looping through the subject. Okay, so in the state we will, sorry, in the state we will have a subjects, right? In the state we will have a subject. This each subject we will be passing to the send method. This will be passed to the send method, and within the send method what we will be doing, we will be calling a generate jog. Okay, then the parameters will be a subject, right? Subject and s. So this is what we are doing. Let me execute it. So what is actually happening, we will have a subject and we are taking the each subject, then we will calling the generate jog. Okay, so and we are passing this state, this subject as the subject to this particular node, the generate node. So this will trigger this generate jog, and this will create the jog. Okay, so I believe that is clear. Now once that is done, what we can do, we can create the best jog node. So for best jog we have a state which is the overall state. Okay, now from the jogs we will do let me do a slash and now I can join, then we have the jog state. We will be combining all jogs together. Now we are creating a prompt. So this is our final prompt, that is the best jog prompt dot format. Okay, here we need to pass two things. One is the topic. The topic will be state topic. Okay, now we need to pass the jogs, which will be our jogs. So once this is done, we need to create a response. Okay, and I can call model with structured output is the best jog. Then I can invoke the prompt. Okay, so here also I can mention is a type of best jog, will help us to do the autocomplete. So once that is done, I can return to the best jog, best selected jog. Okay, this will be best selected jog. Here we can say state of jogs. We can pass the response.id. response.id. Okay, so here we got the best jog. Okay, now we can start building the node and the edges. Okay, which is very simple, and I really love this to do because it's a very easy thing to do. Okay, and we have the overall state. Okay, now I can create a graph. Okay, so first we can do a add node. This will be generate topics, and I can have a generate topic node is there. Next is graph.add node. I can have a generate jog. Here we will have generate jog node. Then graph.add node, we will have a best jog. best joke. Here I can have the best joke. Okay, now this part is done. Okay, now we can add building the edges. So first is graph add edge. Sorry, this will be add edge. We can do a start, then first we will be doing the generate topic. So this is our first node. So once that is done, or this is the first edge, we need to do a conditional edge here from generate topics. Okay, we'll add a continuity joke. Okay, so once that is done, we will be using the generate joke. Okay, so once the generate joke is done, I can have a graph dot add edge. Can have a generate joke, and I can find the best joke. From best joke, we can end it. Can do a end here. Now I can do a compile. For that I can use graph dot compile. Let me execute it. We are getting some errors because generate topics is not reachable, because generate underscore topic is not reachable, which means there is some spelling issues. Let me check that. Generate topic, and here we have a generate topic. Okay, continuity joke already exists, not generate topic. Branch with name continuity joke. Continue to joke. Here we have a start, and we have a generate topic, and we have a add conditional edge. We have a generate topic, continue to joke, and we'll have a generate joke. Let me see this continue joke. Continue joke as send, and we have a generate joke subject. Okay, now let me run it all. Okay, now it's fine. Now we can see how the graph look like. I can use from Python dot display. I can import image. Here I can have an image. Here we can app dot get. Should be get graph dot. Can have a get graph, and here I can have a draw. I've made PNG. We'll see. We have got the exactly what we planned. We have start, we have a generate topic, we have a generate joke, and we have the best joke. Now we can try to execute this. For that we will be using the streaming of data. I can use app.stream. Here I can pass the topics. My topic will be, I can say it as a animals. Let me print as. Can execute it. Let's see. Invalid schema for response format best joke. The properties ID. Okay, there is some issue with the ID. So this is the best joke, which is a ID integer field. Let me come here. Best joke. There is ID is there. Let me check it again. Invalid schema for response best joke in context properties ID. minimum is not permitted, invalid request, parameter request says minimum is not permitted. Okay, here we can do some. Below is the best branch of job. Select the best job and return ID of the best one. Return ID of the best one. So this is our select the best one, and okay, let me run it again. I don't want to restart. I can just directly run it. We'll see. Okay, invalid schema for us. So some issue with the schema. So we have the best job. This is the best job, and this ID that we are passing is an integer description index of the best job starting with 0. GE is equal to just the description. Okay, so let me debug it and let me pause the video and I will debug and figure out. Okay, otherwise like it will take it will be a waste of time for you guys. Okay, so I figure out the problem. The problem is with respect to this GE. So somehow this GE 0 is not working, so let me remove this one. Okay, and let me execute, run it all. So we'll see the result. So this is executing. Okay, see the best selected job will be why did the lion eat the tightrope walker? Because he wanted to well balanced meal. Okay, so this is the best job, and here we can see this is a topic that we have given, and based on the topic, topic is animal. Based on the topic, they have created a few subjects like lions, eagles, dolphin, elephants, and the kangaroos, and based on that they have created the jokes, and from that they selected the best jokes. Okay, so this is how we can implement the LangGraph or MapReduce along with the LangGraph, and we can discuss more about this. Maybe the ideal use case will be creating the summary of a textbook. Okay, so in that we will have a multiple pages will be there. We can use MapReduce to create summary for individual pages. Okay, that we can do. So once that is done, we can combine them together. Then we can create the a final summary of the entire book. Okay, so that is the one use case that we can try it out. So that's it about in this video. So please do like and subscribe. Have a nice day. Bye bye.